Okay, let's go through a couple examples. So the first one you have is a 65 ohm resistor is connected to the terminals of a battery whose EMF is 12 volts and whose internal resistance is 0.5 ohms. Calculate the current in the circuit, the terminal voltage, and the power dissipated by the resistor and by the battery's internal resistance. Okay, make sure you also draw your circuit. Okay, so the first thing you're going to do is draw your circuit. And so here you'll have your battery down at the bottom. So remember, it's made up of your A and B, your positive and negatives, your internal resistance, and there's your EMF. And then you have a resistor on top of that. Okay. Then what you're going to do to solve for it, you're going to use that equation, the VAB equals E minus IR. Remember that V equals IR, so that means IR equals E minus IR. Be careful with your R's to know which one. By the way, this is not the only way to solve this problem. Okay, so simplify and solve. So it ends up being 12 divided by 65.5, and that gives you a current of 0.183 amps. Feel free to pause this as you're going through it, slow down, go through it at your own pace. Okay. Then, to find, for part B, you're going to find the terminal voltage of the battery. So you're going to use that same equation, the VAB equals E minus IR. Remember that your VAB should always be smaller than your E, because your EMF is your ideal voltage that can produce, whereas your VAB is what's actually being produced. So that's always going to be like smaller value. Maybe just a little smaller, but it's always going to be smaller. Okay, so you're going to use 12 minus 1.83 times 0.5 gives you 11.91. And then part C is just taking stuff from last class about how to find the power. Since it asks for the power in each piece, you're going to do it twice. Once for the power through the separate resistor and once through the resistor inside the battery. Okay, so those answers end up being 2.18 watts and 0.017 watts. Okay, for the first one. For the next problem, okay, you're going to compare series and parallel resistors for your two different circuits. So both are connected to a 24-volt battery, and I just want you to find the total current in the circuit and the total resistance, so that REQ of each one. I actually did series first and then parallel. It doesn't matter. If you want to draw the circuits, you can. You don't have to. Unless the problem tells you to do so. So for the first one, to find your series circuit, to find your REQ, you just add them up, R1 plus R2. So 100 plus 100 gives you 200, and then you're just going to use that Ohm's law from last time. V equals I over R, where I equals V over R then, so 24 divided by 200 gives you 0.12 amps. Okay, and that current that you got will also be the current through each of the 100 ohm resistors, since your current is the same everywhere in a series circuit. Then, for your parallel, you're going to use that other equation. So, College Board gives it to you in that 1 over REQ equals 1 over R1 plus 1 over R2. I don't like that format. I prefer to use it REQ equals R1, 1 over R1 plus 1 over R2, and then inverse it. I just think it makes it easier. It doesn't really matter. It's the same equation. It's just reminding you to take the inverse, which you'll have to do no matter which way you do it. So in this case, you're going to find out that your total resistance is less than the individual resistors. So remember, in parallel, as you're adding in those separate pieces, your overall resistance is going to decrease. Since your resistance is lower, that means your current is going to be greater. So if you want the electrons to move faster, put them in parallel as opposed to series. Okay, that 0.48 is the total current through the whole circuit. Since your two resistors are the exact same size for this one, that means you have 0.24 amps running through one resistor, 0.24 amps running through the second resistor. So that way, if you add 0.24 and 0.24, you'd get 0.48. Okay, the last example is actually looking at a combo circuit, finding the equivalent resistance in the circuit. So what you want to do is actually draw this out in a straight line. I think that really helps to break it up like that, because if you look at the circuit right now, for example, the 0.5 ohm and the 6 ohm, yes, they're parallel to each other, but they're not on separate pathways. So the 6 and the 0.5 are actually in series with one another. And so I think that it'll actually help you see that a little bit better if you draw it out in a straight line. So what you want to do also on a combo circuit is separate it out into pieces. So if you look at this 8 and the 4 ohm resistor right here in the middle, those two are in parallel with one another, but they're in series with the 6 ohm. So if you go through the 6 ohm resistor, you have to go through this 8 and the 4 ohm, well, one of the pieces. So you want to first start here and add your 8 and your 4 ohm resistor in parallel. So 1 over 8 plus 1 over 4. Get that answer and then redraw your circuit. I know it's going to take a while to redraw your circuit, but I think it'll really help. So then you'll redraw it, but instead of this piece being in parallel, now it'll be one single resistor in series with the 6 ohm. And then you can add those two resistors in series and keep going, okay, to simplify your circuit down. So what I did is I did it in multiple steps that you can see, okay. So I'll zoom in a little bit. So here's the top picture. Here's your battery. You go through the 0.5 ohm resistor first because that's in the battery. Then you hit point A. Then you split and you either go through the 10 ohm resistor or you go through this mess in the bottom. And then they come back together and everything has to go through the 5 ohm. So I started with the 8 and the 4 and added those in parallel. So 1 over 8 plus 1 over 4, inverse that. And that gave me 2.67. So instead of having these two pieces, now I have one resistor here that's 2.67. And then I simplified this, so 2.67 and the 6 are in series with one another. So I add those two up and that gives me 8.67. So I'm just redrawing the pieces that I'm doing. Everything else just stays the same. Then I have a 10 ohm resistor in parallel with my 8.6 ohm resistor. So I add those up again. 1 over 10 plus 1 over 8.67, inverse that. And that gives me 4.64. You can always check your math as you're going through it. If your parallel pieces ever end up being bigger than the individual ones, you're wrong. So just go through and double check. And then you end up with having 3 resistors in series with one another. The 0.5, the 4.64, and the 5. Add those 3 up in series and gives you a total resistance of 10.14. So instead of having this crazy complicated circuit, now you have just one simple resistor of 10.14 ohms.